We start by assuming that the square root of 5 is rational, meaning it can be written as a fraction a over b, where a and b are integers with no common factors other than 1. If the square root of 5 equals a over b, then squaring both sides gives 5 equals a squared over b squared. Multiplying both sides by b squared results in 5 times b squared equals a squared. Since 5 divides a squared, it must also divide a, so we can express a as 5 times an integer k. Substituting a equals 5k into a squared gives a squared equals 25 times k squared. Replacing a squared in the equation 5b squared equals a squared gives 5b squared equals 25k squared, which simplifies to b squared equals 5k squared. Because 5 divides b squared, 5 must also divide b. If both a and b are divisible by 5, then their greatest common divisor is at least 5, contradicting the initial assumption that it is 1. This contradiction shows that the original assumption is false. Therefore, the square root of 5 is irrational. Assume square root of 5 equals a over b in lowest terms. Squaring gives 5b squared equals a squared. Because 5 divides a squared, a is a multiple of 5. Substitution shows that 5 also divides b. Then a and b share a factor of 5, contradicting lowest terms, so square root of 5 is irrational.